have 10 more minutes until this is supposed to start. But I figure if I get started early, maybe we get end early or more time for questions. So, welcome everybody. My name is Ben Pomerenke. I'm here. I work for Worldwide Technology. We do custom software development for mostly Fortune 500 companies, bigger companies that you probably all heard of. I can't necessarily share who they are, but we do team-based consulting. So we will take anywhere from 5 to 25 developers, QA, front engineers, a bunch of different roles, and we will work on a project for a company for 6 to 9 months. They pay us a decent amount of money to do that, and then we move on and go work on some other company's problem. So we've been around for, I think, Worldwide Technology has been around for 30 years. The division I'm part of started 20 years ago. The custom software side started about 20 years ago. I think within the first 5 or 10 years, we started doing test-driven development, and that's what I'm going to talk about today. So I mentioned a little bit about myself. I do want to call out that my partner in crime, who is supposed to help me present today, is not here, Adam Fox. So Adam has 11 years in the industry, started doing TDD 3 years ago when he joined WWT. He is experienced in React, Angular, and Node.js. You'll notice a common theme there, and that is because he is a front-end engineer. So front-end engineers at Worldwide Technology typically focus on web tech, front-end web tech. So these web front-ends, they also kind of blend into our UX consultants. So they do a lot of styling, a lot of user experience, accessibility, things like that. But we kind of make them work with the developers in test driving all that code. So it's a lot of code. They have the design eye, the developers have the engineering eye, and together we work together to test drive that code. I've been in the industry for a little more than 14 years. I did start TDD 10 years ago when I joined WWT. You'll notice that the technologies I list, so I have a lot of technology experience, .NET, Node.js, Angular, AWS, and Terraform, but you'll notice React is not in that list. So I'm going to attempt to write some React code tonight for maybe the second time ever. I am a software developer at Worldwide Technology. However, 6 years ago, we opened an office here in Springfield, changed my role a little bit. I now have the title of Technical Operations Manager. That means that I just make sure we exist in a good way within our company. I get to write code a lot, but I also worry about other things, like making sure we can fit in the building we have. That we hire good people, things like that. We're actually located just down the street, Phelps and Campbell. It is a glorified storage unit right now because our office is currently closed due to COVID. Hopefully we will be back September timeframe. All right, so a little bit about test-driven development. So what is TDD? Well, I can tell you a lot about why it's good, whatever, but it really comes down to a very simple premise. It is a robust way and highly disciplined way of writing software. Okay? It has tests in it. It has some refactoring. It has a bunch of things that make it work. But the core concept is that you are disciplined in building your software, right? So why would you want to do it? Well, the reality is that, like most things in software, it does depend. Sometimes you want to use it to help make a better architecture or to see different architectural patterns before you run into them. You may want to do something as simple as prevent regressions. Maybe you're building something that can't fail. Think the space program has to send things out in space, and if their calculations are wrong, somebody might die. They may want to use something like test-driven development to develop their code. One of the nice things is it enables safe refactors. So if you have automated tests that will prove that you didn't break any of the behavior, you can now go crazy on the code. And as long as those tests pass, you haven't broken anything. So it gives you a lot of safety in actually being able to refactor the code. It can give you robust test coverage. So unlike test after development, where you write the test after you've written the code, test-driven development has some rules in place that ensure that you don't write any code until there's a test that covers it. So typically, a test-driven development code base will have higher levels of code coverage. The thing I probably like about it the most is the test can serve as your documentation. So whereas code can tell you what something does, a test can describe why it does what it does. So you can put in the reasoning behind why you're doing some of the things you're doing in your code in the actual tests. And when you run them, it'll say, what the test is. Think about, 5 million line code base. There's going to be a lot of behaviors in there that do a lot of things for a lot of good reasons. Nobody can remember everything. So having tests in there that kind of give you that, it does this, it does this, it does this, and maybe the why behind that is very helpful. Another thing I really like about it is that it actually changes your perspective in a good way. So instead of thinking about what code am I going to write to make the app behave the way I want to behave, you start thinking about what do I need to do to verify it works the way I expect it to. So it puts you in a slightly different perspective. A lot of people will say when you do TDD, you spend more time writing tests than you do production code. And the reason for that is the tests are the actual proof that the code works. So it's not actually a bad thing that you're spending time writing code for tests more often. And then last one, and this is the one I'm going to show you tonight, this will enable novice developers in that tech stack to be able to contribute early in a project. So if I go into a project, and this is particularly valuable for WWT because we work in teams. If I go into a project and I don't know the tech stack, tests can help give me the confidence that I didn't screw something up. So maybe I'm working with an expert React developer. I go in and I want to just tweak a little bit of behavior. I want to add something new. I'm not quite sure I didn't break something else. The test can give me that verification and give me that confidence that helps me contribute early and often as I grow my skills in the tech stack. So those benefits are all great. And this is, I could talk for hours about why I love doing TDD. But I will say there are a lot of common misunderstandings. So I just want to cover a few of them. So number one, it takes more time and it's more expensive. Some people think I can't afford to do test-driven development. It'll take me more time. It does take you a little bit more time if you don't know how to do test-driven development. Once you get in the habit and once you understand the flow of it, it actually can help you go faster. It can help you stop worrying about things that you're not sure if they're going to work or not. You have a test that cannot tell you if they'll work. You could argue it's more expensive if it takes more time, especially up front when you have to set all the code up. However, I would argue that software development, the most expensive thing in software development, is either fixing broken software, right? So fixing bugs takes way more time than building the software right the first time. The second thing is losing your actual users to the software. If they use a piece of software that has bugs in it or is flaky or works one day and then you release an update and it stops working, they're just going to stop using your software. They may stop paying for it. They may start bad-mouthing. They may start downvoting it in the App Store so that nobody else wants to download it. Those are very expensive things around software. So it's a little bit more expensive maybe to write the software when you do test-driven development. However, it saves you a lot of money in the long run. So it's a good investment. The other one is I can write tests afterwards if I need them just fine. So a lot of people will say, I just got to get something out there. I'll backfill the test afterwards to give me all those benefits that you talked about. I can just write the test afterwards. That will work to some extent. However, software is very complex, and it gets very complex very quickly. So you don't actually know the little nuances that have been designed into software once it gets to a certain level of maturity. So yes, you may be able to backfill tests for one component, one piece of the software after the fact. And actually, sometimes when you're first learning TDD, that's what we tell people they should do. They should design the software first and then figure out how the tests work, just to understand the testing mechanism. But if you do that long term, what ends up happening is you either stop writing the tests altogether, because they're an afterthought, or you start giving yourself a false sense of security that you actually have good test coverage. And the kinds of things you actually forget to test are actually the things that end up breaking your software. So doing tests first and following some strict patterns on how to do that actually ensures that you have good test coverage long term. And the last thing is tests get in the way of reworking architecture. So this is actually something that comes up a lot with novice test-driven development folks. So people that learn how to do TDD, they develop a code base in TDD, and all of a sudden they're like, now that I look at the code, it looks like it needs to be architected differently. And by the way, now that I want to re-architect it, now the tests all break and I have to worry about them too. Okay? That is true. That will happen sometimes. But the reality is if you're testing it correctly, that should very rarely happen. Most of the time what happens is people are testing things too tightly, or they've designed something too tightly coupled to the tests, and they find it really hard to decouple it once they want to rework it. So I'm going to talk a little bit later about different testing strategies, different kinds of tests that can give you those layers of flexibility, and we actually will put them all together in our code bases. All right, any questions before I get into what the details are? Any zealots want to convince me that one of these misunderstandings is actually true?
Well, show us tonight already.
Yeah?
So I've got a question. Not that I want to prove any of these to be untrue. I'm curious. So I'll admit I've never written a test in my entire career. Okay. So probably not too crazy of a thing for you to hear, I suppose. I'm curious, when you personally speaking, any project you work on, test-driven development?
If the code is going to hit production for a paying customer, yes, test-driven development.
How about for a pet project?
A pet project that I expect to live beyond the week I'm working on it, I will add tests.
So by and large, testing pretty much all the time, unless it's a scrap piece of something.
Yeah. Now, I will say, caveat that with, if I'm learning a new tech, I usually don't learn testing first.
Sure.
I usually think to myself, I got to understand how the tech works before I can write tests around it.
I kind of get depressed anytime I hear you talking about this, because I'm like, this is inspiring. This is awesome. Why can't I do it? Yeah.
I will say, test-driven development is actually not easy to do, but writing some languages isn't easy to do either. I would argue that some people think cloud, articulating cloud-based services is hard to do. It's one of those things that it is hard, but it's worth learning how to produce better software for your customers. So I was just telling Mike actually before, we have a lot of debates. So because we mostly do test-driven development, we like to argue the finer points of it. So there's this whole debate over whether you should use mocks, which is what we call a class assist way of doing testing, versus doing behavior-driven development or like black box testing. And there will be people that will debate it for hours. Like they could lose half the day just debating that problem. But over time, the more you hear the debates and the more you have those conversations, what you start realizing is there's no real right answer. I mean, it's the same thing as, arguing whether it's, too cold to wear shorts today. It's going to be somebody's personal preference. At the end of the day, when you build the software, knowing how to navigate between the different approaches is probably the more important thing, because you run into situations that some approaches don't really work well for. So, any other questions?
Can you test both in the same project?
Test.
Like you were saying, people argue back and forth about. Can you use both of them in the same project?
Yes, and you actually probably should. There are some things that one approach is really good for. So mocking is really good for testing any kind of logic that interacts with like a third-party integration. So like say a database, right? So a lot of times we'll have some logic that happens in our database layer within the app. So not in SQL, but in the app. Those things are better to mock because you can actually fake out the behavior of your third-party library, the ORM. There are sometimes they're good to mock also because the cost of loading in the actual software makes your test run too long. So, a lot of times what we'll do is we'll have the mocked version of our test that go really, really fast, and they just prove like, did we do the calculation correctly? And we can have hundreds of those, maybe thousands of those in our code base. And then we'll have maybe one or two integration layer tests that will actually do more of a black box test. I try to save something to the database and it works. And they may actually spin up a database, try to save the data, and then fetch it back out and make sure it got in the database. So mixing and matching is actually what I would say is the best strategy, because different problems have different tools that work. Anything else? All right, I'm gonna move on. So I talked about this really hard to master thing, but the funny thing is it comes down to like some very basic rules. Okay, so the first, it actually all comes down to 3 rules. Okay, these are called Uncle Bob's rules. So Bob, is one of the founders of the Agile Alliance. I can't remember his name off the top of my head. He actually came up with these rules, 15, 20 years ago. And if you follow them pretty closely, everything evolves from there. So first rule, and these are a little bit verbose. First rule is you're not allowed to write any production code unless it is to make a failing unit test pass. Okay. Second one, you're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. Okay. So the joke is the first passing test is does it compile. Right. And then lastly, you're not allowed to write any more production code than is sufficient to pass the one failing unit test. Okay. So the simpler version of this is you only write enough of the unit test to fail. And then you only write enough production code to make the unit test pass. Okay. And typically you'll make, once you get into a complex scenario, you'll make one unit test pass that drives the next piece of behavior. By it passing, it may fail other unit tests that now need to be modified to accommodate that behavior. And so that's why these simple rules, they just kind of step you through the code bit by bit, and you just kind of methodically move through it. Okay. These rules are really nice for another thing we do at Worldwide Technology, which is called pair programming. So we can actually have one of the people do write just enough code to make, or just enough code to make a failing test, and then we can have the other person write just enough code to make it pass. We can kind of ping pong back and forth for hours. It actually, sometimes you forget you're doing it, and then you look up and you're like, oh crap, it's time to leave. So those rules are the foundation for test-driven development. Okay, and you can go beyond just unit testing. So this is specifically talking about unit testing, but you can make this true for all layers of testing. So in a little bit, I'll talk about the different kinds of testing you can do. You can say, I'm not even going to build an app until I have a test that says I should have an app. Like I should be able to hit a URL and something comes back. That's like the most basic test. You wouldn't write that in a unit test framework, but you could start there. And until you get that to pass, you can't call the work done. Okay, and you kind of just step in layer by layer by layer. While you're actually doing this process, we have kind of that loop, what we call red, green, refactor. So red is where you write the failing test. Green is where you make it pass. And then the most important aspect of TDD that we teach all of our employees is that last step. It's the refactor. The refactor is where you get all of the benefits of that methodical approach. And it's where you get you have the highest chance of getting your code to be well architected, clean, and highly maintainable for future use. And so every time you make a test pass, we always kind of pause and you step back and say, is there something we could have done better? And if there was, you do it then, and then you move on. So just little by little, you're keeping the code clean along the way. The basics of a unit test, or any test for that matter, is the next part: arrange, act, assert. So every test you do will do all 3 of these parts of the process. So the arrange step is where you set up the world for your test. So any dependencies you may have, any data you may need to use in the actual test, that's what you do during the arrange step. Now it usually comes at the beginning of the test. After that, you do the act step. This is where you take actions, you execute code, you do something that's going to cause a result. Okay, so in this case, it's actually calling the test object isEmpty method, okay, and saving away the result to be asserted on. And the last part is the assertion. So this is where you actually prove, you test that what you expected to happen actually happened. Okay. Typically when I teach people how to write tests for the first time, or when you're first getting into unit testing or any kind of testing, I typically tell people to start at the end. Start at the, what do you expect to happen? Do you expect a value to change? Do you expect a result to come back? And that kind of defines kind of what the consumption of your method, function, class is going to be. Then you move up to the act part. So how do you want to make that happen? Okay, am I going to call a method? Am I going to pass it a parameter? Am I going to take two numbers together? And so then that happens in the act part. And then from there, you can actually, between the act and the assert, you can actually derive all your dependencies for the arrange part. So some people get kind of frozen when they go to write a test. They're like, I don't know what I need to set up. Well, most of the time, I don't know what I need to set up either. I always start at the end. I always say, what do I expect to happen? And then I work backwards. Okay. When you actually go to do this, there's a lot of different tools that you can use. So almost every language has a testing tool. Now, 10 years ago, that wasn't true. 10 years ago, there were some languages like Erlang, or I think iOS maybe didn't even have testing tools 10 years ago. But by now, this is a popular enough process that almost everybody produces a testing library and puts it with their language. For instance, like today, I'm going to be showing you React with some testing. If you use Create React App, it automatically generates some basic fixtures for you. I know Angular does the same thing. So a lot of these kind of out-of-the-box frameworks, they actually will provide you the test harness along with the actual code to test. I don't know how many of you guys have used those tools, but I've seen people that don't do TDD use those tools, and basically the tests stay empty the entire time. But they're there for a reason. Google and Facebook thought it was important that you guys had the ability to write tests. It's also built into most IDEs, so the IDEs will usually give you like quick shortcuts to run the test, or they'll let you put a watcher on the test themselves, and really that's just to give you faster feedback. You want to make the test feedback loop as seamless as possible, so you don't have to think about it. Right? It should be as easy as compiling code. So a lot of times we'll wire up like a control or a command TT to run the last run test. So when you're doing that red-green refactor, you want to make it as quick as possible to rerun the last run test. On the left side or right side for you guys, you'll actually see some examples. So what I wanted to call out here is every language looks a little different when you have these tests. But if you kind of squint your eyes a little bit, you can see they're all actually structured very similar. So tests usually have this concept of a fixture. It's like a group of tests. Usually you'll have a fixture per class. You may have a fixture per domain, like if there's a class of interaction in the app, you may have a fixture for it. And that fixture will have a setup method. So in JUnit, you denote the setup method with an annotation of before. In InUnit, it's a little bracket annotation that says setup. And then in Mocha, it'll actually, I don't have that example, it's actually a method called before each or before all that just kind of goes right before your test. And then every fixture will have a number of tests. So usually, tests are kind of like lines of code of the class. 10 or 20 is probably the most you'd ever want to see in a fixture. Once you start getting into those high numbers, your class or your thing under test is probably too complex. Just like you kind of want to limit classes to be 10 to 50 lines. You want to be able to read them quickly. Same thing is kind of true with tests. If you have too many tests, it probably means you're doing it too complex. Which is one of the benefits of TDD. By having to write these tests, it gives you one more signal that maybe I'm not designing my code the best. The tests are too complex. They're too tightly coupled to the code. There's a lot of things you can get from writing these tests, like secondary and tertiary feedback mechanisms. Any question about the syntax? I know it's hard to see. Sorry, do I need to stop moving?
Yes.
Okay, I'll stop moving. Just my natural wave. All right, moving on. So I mentioned earlier there's a bunch of different kinds of tests. And so typically you'll see what's called the testing pyramid. It turns out that this isn't actually probably the most realistic thing, but what this picture does a good job of describing is how the quantity of these tests should exist in your code base, and for a lot of different reasons. So the red bar shows you that as you go further up on the pyramid, the tests themselves become more brittle. So unit tests are probably the least brittle thing. right? You're just testing little units of code. The code compiles, the test compiles. You'd really have to screw something up to have a side effect that would actually make that test fail. And so typically you have a ton of those unit tests. They're everywhere in the code. Every line of code you write probably is covered by a unit test or a couple. And they're super fast to run. The next layer above that is the integration test. So integration tests are really where you take two or more components of your system and you glue them together to make sure they work together. So think about a database layer. If you have something interacting with your actual database, and then maybe if you have like an MVP or MVC pattern where you have a controller that interacts with that data layer, you may want to wire up the controller and the data layer together and prove that the controller can get all the way down to the database. Okay. So that's an example of an integration test. You may also want to test things like configuration. So a lot of times, a lot of our code now uses annotations and conventions to decide how code maps to, say, a URL. You can't really test that with a unit test. You can't really test configuration very well with a unit test. So you may need to actually spin up the app and prove that it wired up the configuration in a good way. So those are good things for integration tests. And a lot of the actual technologies are making it easier and easier to do those things very quickly. So integration tests can range from super fast, more, it looks a lot like a unit test, to super slow, depending on what you're actually doing. And the technologies are trying to make them faster and faster, so it's easier to glue stuff together. And then the last class of test is the end-to-end test. So this is where you take the entire system, put it together like it's going to happen in production, and you use it from a user's perspective. This is typically where you'll see things like browser click tests or device click tests, things that actually interact with the software like a user would. And they prove that the entire system is up and running in a good way. Okay, so if you do like cloud deployments, you'd probably actually deploy the app to the cloud before you run these tests. And you'd probably run them against a deployed environment. They're supposed to run against as realistic as possible environment, which is one of the reasons you have very few of them. So there's only certain classes of things that are highly risky to be broken in actual deployed environments. And so you want to focus your energy on making sure those work. So for instance, if you have an app that has a login and a user goes and tries to log in and they get a 404, I can't find the page, that's a pretty bad error for a user to see. So you may want to have an end-to-end test that just hits the deployed environment and proves that the app can actually log in. Okay? You may not want to have it log in and do all the work. You just want to prove that it'll log in. And then the very last class of testing that we want to try to avoid if we can, but it's unavoidable because it's very important that humans use our software. So we do have a level of manual tests. You could argue those are the most brittle. If your tester or the person that knows the software really well wins the lottery, those tests all break. Right? You don't have anybody to verify it. So though people that do testing, software testing, are very good at what they do. I personally like putting all of my energy in getting what's in their brain, all the test cases they can think of, and making them in code. Because then they can go win the lottery and never be around, and we're still okay. Sorry, I keep moving. Can't stop.
I feel ya.
Any questions about this model? And then last, I'm going to talk about the role of continuous integration and continuous deployment. We talked about all these processes that make your code better. They give you this nice test coverage. They help prevent things from breaking, or they give you those feedback mechanisms you may want. But it's important that you leverage software to actually run those tests consistently. So we will typically, everything we build for our customers, we always will set up a continuous integration and continuous deployment pipeline. So we'll always compile the code, we'll always run all the tests, and if we can, we'll deploy it to a prod-like environment. And that proves that our entire delivery mechanism for that software works, and that along the way, we didn't break something. Okay? Those tests will run 10, 50, 100 times a day for a team that's making a decent amount of changes to code base. That's 50 times a day that somebody didn't have to think, I need to run my tests. they happen automatically. So building in those feedback loops automatically as you call work done, it's very important. So I've seen a lot of people write beautiful tests, have a whole awesome test suite that proves the app works. They don't run it for 3 weeks, and when they go to run it again, everything's broken. And it's not broken for a bad reason. They changed like some default data. But pinpointing where the problem was is so hard 3 weeks later. This literally happened to my team this morning. So I'm working with the team from India, and yesterday I was supposed to do some work on the CI/CD pipeline, and I'm like, okay, can you run the test locally? They're like, no, they all fail. I was like, why do they fail? They're like, well, we haven't ran them in 3 weeks. So we haven't integrated into the test pipeline yet. And you know, these awesome tests they wrote just stopped working one day. So I mentioned already, you don't want to rely on humans to run these. We're lazy. We forget to do things. You know, sometimes it's a little tedious to run a few commands and wait for it. So we like to offload all of that work onto the computers. They're really cheap. They don't complain. They'll do the work for you. Okay? So if you don't have, skills like running, setting up these more complex CI/CD pipelines, something as simple as a timer on your machine that runs them, batch process on your current machine that runs the tests as you would expect to run it would be better than nothing. This also helps another important aspect of tests, which is it helps you pay attention to the execution time. So tests are a feedback mechanism. They tell you whether you did something wrong. If it takes 30 minutes to tell you did something wrong, it's not it doesn't help you very much, right? That's 30 minutes of work you could have been doing in the wrong direction. So you want to keep the test runtime down to a minimum. You also want to run the faster tests first to get that feedback sooner. All right, so when we design our CI/CD pipelines, the first thing we always run is unit tests. If they pass the unit test, then we worry about running integration tests. If they pass the integration test, then we deploy the software. The deployment works, then we run the end-to-end tests. So that could take, 5 to 15 minutes, depending on how complex your software is. But if a test is failing, you would know within 30 seconds. If a unit test was failing. Integration test, you would know within 2 minutes. Deployment fails, you'd know within 8 minutes. And if the end-to-end tests fail, you know within 15 minutes. So those fast feedback loops, or limiting how much work you can do while it's going to fail, like if it just hasn't ran the test, it's really important to pay attention to that and design your tools so that you can get as fast feedback as possible. And as I mentioned earlier, the first passing test you need is a compilation. So you always want to have it compile first before it starts running the tests. All right. So now we're going to try to do a demo. Like I said before, I don't actually know React.
What are all those things?
That's a good question. So these are the technologies in the demo that you'll see a little bit of. I'm not going to be able to go deep into them because I don't know them. So the Squid is actually a framework called testing library, React testing library. So it's the thing that comes by default with Create React App. Jest is going to be the library that's used to do the assertions. So when we do our assertions, it's using Jest. TSLint, I don't even think I have that set up. That was for Adam's demo. Helps you not worry about code formatting. So once again, trying to speed up those feedback loops, not worry about things that computers can do better than you anyways. And then we're going to be doing this in React. All right, here we go. So I'm going to be using Visual Studio Code. Let's see. Is that readable? Or do I need to go bigger? What about you guys in the back? Can you see? No. There's gonna be limits to what I can do if it's too big. Can you read that better? Better? Okay, cool. That's probably my limit anyways. All right, so I have a few things going on here. So if you're not familiar with React or Create React App, the default setup comes with a kind of pre-formatted package JSON that has a few different things. So it just has the way to start the actual app. You can build it to package it up for production, and it has the ability to run the tests. So I'm going to leverage 2 of those commands today. So the first thing I'm going to do is start the app. So I'm going to do yarn start, and I already installed all the dependencies and everything before I came. So that should launch the app in the browser. And this has been a slightly modified Create React app. So give it a second. My computer's a little slow. All right, so here is our actual app. So we're going to make a to-do list, at least a few parts of a to-do list. Like I said, I don't know React, so I can't go too complicated. So this, assume you're dropping into a team. They've got the app started for you, and you need to build the next piece of behavior. Okay, so right now all the app does is tell you there's nothing in the list. The good thing is, though, is the developers that started this app actually did it in a test-driven way. So I'm going to go ahead and this little terminal down below, I'm actually going to do yarn test. Okay. The reason I'm choosing a terminal that's in the same window as my actual code is because I want that fast feedback. Right? So I want to be able to change code and see the test run again without having to swap to a different screen. Oops, wrong one. Okay. Now, the default behavior of the React test is that it will run these tests in what's called a watch mode. So it's watching for file changes. So as I save either the test itself or the code under test, it'll automatically rerun the test again. Oh no. Did I start with a failing test?
That's what you're supposed to do, right?
Well, I wasn't expecting one to be failing. Okay. Let me see if I probably deleted something I shouldn't. Oh, I know why. Okay, so, sorry, I went a little bit overzealous on deleting stuff. Okay, so I'm starting in a place where everything's passing, right? So the test pass. So this app is composed, it's very basic. You got your main app that has some, header, title, things like that. And then it has one component inside of it. It's called this to-do list. Okay, and it takes a list of initial to-dos. So think of, an API loads the initial list. So this component's going to take in that initial list, and then it's going to act on it. Okay, in the component, there's some very basic setup. So hopefully, if you're familiar with React, you'll notice we're passing in that initial property. Okay, so these are what are called the props. And so that's kind of the initialization of the component. And then I do have some basic setup with the state. So I have a variable called to-dos that can be updated using set to-dos, and it initializes that with that initial prop value, those initial to-dos that come in through the usage. I have this concept of a new to-do, which is for adding new ones. And then I have a few methods that I have implemented for my safety's sake that are actually going to be doing the work of adding the to-dos. So they're not actually being called at the moment. And then inside the body, just have some basic stuff. So I have a header with a unordered list that currently has nothing in it. I have a little check for whether or not there are any to-dos, and if there aren't any, I put there is nothing here. And then I have a little form down below that's actually for adding the new to-dos. Okay? A lot of this stuff is just straight up markup. So there's no actual tests that prove the markups there. What we're going to be testing today is the behavior that the user will go through to interact with the markup. Okay. As I mentioned before, we do have some tests here, so that behavior around checking whether or not there are any to-dos is tested here. This testing library, kind of just to show you kind of the ropes before I actually write some tests. The arrange is rendering the actual component. So this render line, it's going to actually in memory render that component. The act is actually grabbing an element from that component. So think of it as like this is what the user would see if it was in a browser. So it's going to say screen, get me an element by role. In this case, it's looking for a list. And then the last part is the assert, and it's expecting, so the assertions here is that the list has nothing in it, and that the screen has a message that says there is nothing here. That's just an example of what a test might look like. All right, so next I'm going to add a little bit of behavior. So I'm going to add, I want to say, well, what if I actually have some to-dos? Like what if I send in to-dos on the initial to-dos? What do I expect to happen? Okay, so I'm going to write that test. So I start off by just writing the test. So you give it a name. So this is typically what the behavior is. So renders initial to-dos. Okay, my code actually has a place where that list can go, but it doesn't actually show it. And the test itself is going to do a few things. So first of all, I'm going to set up the initial data. So let's assume we got this variable called existing to-dos, and it's just going to be a list of strings. So A, B, so on and so forth. And I'm going to render that component with those to-dos passed in. I'm passing those initial to-dos. Okay, so that's my arrange. And then my act is going to be I'm going to go actually grab an element from the rendered page. So once again, I'm going to fetch a list. Okay. And in this case, instead of expecting that it's empty, I'm going to expect that it has the number of items I expect. So I'm going to do an expect list.children.length. In this case, I expect it to be equal to 2. Okay? And I can go even further than that. I can actually prove that the ones I expect to be there are actually there. So I can actually look at the actual rendered text. So if I say list.children, let's say I want the first one, and I should say to have text containing, or should have text content. I can say I actually expect to see the letter A. And similarly, I expect to see the second one in the list. Maybe. Sorry, not my normal keyboard. Second one on the list will have the value of B. Okay. So assuming that's the test I want to write, or the test I think I want to write, I can save it and I'll go ahead and run it. And typically you know this test is going to fail, but sometimes they actually pass. Sometimes you accidentally test a behavior that already exists. Very rare, but it happens. But it's always important to see that red first. So I see one failed. In the output I can actually scroll up and it can say, it'll tell me why. So it actually failed on the expectation that it expected to see 2 items in that list, but it actually found 0. That's because I haven't implemented any code to put any items in the list. Okay? A lot of times you'll notice like I put assertions that are kind of duplicative. So a lot of times I'll always check things like count before I actually check that the values that I expect are there. So what that is, it's a faster feedback loop. It's a lot easier to understand that this says expected 2, but got 0. If I take that assertion away and run the test again, you'll actually see the assertion, the output won't make as much sense. So the more you do this, you kind of start designing your test to give you the easier failure first. Yes. So this says the received must be a node, and it was undefined. It's actually not that bad of a response. I like the number one, though, better. All right, so now to implement the code. So that's the red part. The green part, so like I said, if we're pairing, this would be where my pair takes over and actually writes production code. Which is, I was hoping Adam would be here and he would write the production code. So I'm going to write a little bit of React code here. So I'm going to take those initial to-dos, map them. I'm going to put a list element. So React requires that I have a key for that. I'm just going to put the name or the to-do itself as the key. And then I'm going to render the text. Okay. Now, hopefully this makes the test pass. Come on. Yay, it passed. There's my green. All right. So, sorry, I'm a little extra excited because one of these times something's not going to pass. I'm not going to know how to fix it. All right. So the last step of TDD is refactor, right? So this is where you can start putting stylistic changes in here. So once again, if you're pairing, maybe I implemented it in a way that isn't kosher with the person I'm pairing with. Maybe they're a zealot about spacing or tabbing or whatever. This is where they could go in and fix it and make it like they want. Like I said, though, linters usually will do that for you, so that happens less and less these days. One thing I am noticing, though, is my test itself could be a little bit better. So in this test, I actually have a few things that are potentially brittle, right? So I have existing to-dos A and B, and then I assert that there's definitely 2 of them. So I could maybe make that a little bit more based on the input. So I could say something like existing to-dos dot length. And so I can make it a little bit better, a little bit more robust of an assertion. So whatever I sent in, that's all I care about is the thing that comes out matches the thing that went in. Similarly, I could make these better too. So I can kind of potentially create a little bit of an echo chamber, but it makes it so my code's a little drier. I have less hard-coded variables in the test. And then if I decide, hey, I wonder how this behaves with 3 things. I can prove that it actually still works just fine. So sometimes the refactor step is how do you make your test a better test? How do you make it easier to read the test? How do you make a cleaner version of the test? Okay. All right, next one. We're going to make it so that you can actually add things to the to-do list. By the way, before I go on to that, you can see that I reload my app. I got that one to-do 1 is in there, and that's because I initialized that in the app TSX. Okay, so I have 1 to do. So the next thing I'm going to do is wire up this form here so that if I put foobar and hit save, it'll actually add that to the list, which it's currently not doing that. Okay. So once again, I'm going to jump into the test. I'm going to describe the behavior I expect, kind of in words like I just used. So test can add item to list. Okay, so in this style, I just want to think through what would the user do. And they're going to take the text box, they're going to put text into it, they're going to hit that save button, and then I should expect it to show up in the list. Okay. So I'm going to go ahead and grab a text box. Actually, before I do that, I need to render the component. Just going to send a no initial to-dos. And then I need to grab a text box. I think if I roll. And then I'm going to use this thing called the user event to actually type into it. So I'm going to type into the input word boosh, my favorite test string. All right, then I'm going to find the button. Okay. Now I can do these very generic lookups because I'm designing my React code to be very modular. So I'm only in the context of that module or that component. Okay. One of the things that a lot of people will run into is they're like, oh, I got to add things like test IDs, or I got to make things easy to find. Well, that's kind of a smell in its own right. So if you have to do a lot of work to make the tests actually be able to test the code, you're probably not designing your software very well. And so in this case, I can just say this component only has one text box and one button. And that's good. That's a good thing. Once I have another button that has nothing to do with this behavior, maybe that's a good signal that I should create another component. Maybe make it a smaller bite-sized piece. Okay. So for that button, I'm going to click it. So another user event. And then lastly, I'm going to assert on whether or not it showed up in the list. So like the test before, I'm going to grab the list. And I'm going to assert on it. So I'm going to put text.children.length to equal 1. And I'm going to expect list.children at 0 to contain to have text containing or to have text content of boosh. Okay, so pretty straightforward. You can kind of read these like what actually is happening in the app. I'm going to save that. I expect it to, but once again, I'm new to this. There we go. There's my one failing test. If I look at why it's failing, it expected to see something in the list, but it got nothing. Okay. So going into the React code, like I said earlier, I have these little helper methods that I was afraid I would screw up, so I just left them in there. So what they do is the handle change actually, every time you change the text box, it's updating a property called new to do. So just updating it in real time. And then save to do is where it actually will push it onto the list and change the, update the state such that it re-renders the component. Okay, so I just need to wire those up. So the text field, I'm going to give it a value of new to do. And on change will be handle change. Okay. And then on the button, I'm going to add the one click. I'm just going to have it call that save to do. Okay. When I save it, it's going to rerun the test. It's failing still. Okay. And now in my feedback, I'm actually seeing I had a bad test. So it expected a capital B boosh, but was a lowercase b boosh. One reason that's also nice to extract variables here. So just have a bad assertion there, which happens actually more than I'd like it to. Come on. There we go, all passing. Okay, once again, refactor step. Maybe save myself from accidentally making the same mistake again. I usually like to pull out these for the setup. Just pull that magic string into a variable. There we go. Hopefully it's going to pass here. All right. That's all I have to show. That's my limited React skills. Any questions on the code demo? And please avoid React questions. Cannot answer those. Fred.
I'm not going to avoid a React question. No, I'm just kidding. Can you go into detail a little bit about how you architecture code by working from the ground up, like working from the expected to from the assertion to the actions, and then finally to the setup? Can you go into a little bit more depth to that? Because, I mean, for me, one of the missing clicks for test-driven development was that step of thinking about, and when it comes to doing architecture, was that step right there, working from backwards up, and let the user experience define the architecture of the code. So can you elaborate on that here?
So I think you're talking about two different things, but the thing that I think you probably actually care about is how does this inform architecture?
Yes.
So the style of tests that I'm actually writing do a really good job of informing architecture. You'll notice they don't say anything about the innards of the component itself. They're very outward consumption based, like how a user interacts with this component. So all the things like whether or not it used, a button or an input or like a label that's styled like a button, it doesn't care. It just says, I want something that's playing the role of a button. So the style in which you design the tests can decide whether or not you have that flexibility of the architecture. So in this case, by writing tests that only are testing behavior of the user, that gives carte blanche to the actual architecture decisions that happen in the code. So typically, red-green refactor, those decisions that you would make for making it good architecture would happen in that refactor step. So maybe breaking something like this out into I think this is valid, into like a helper function or something like that might be something that you may want to do. Hopefully this works. Right, so if you wanted to extract like a regular, what did I do wrong there? Like that. Like extracting a method or making your code better formatted, maybe even taking that method and extracting it out to its own class. You should be able to do that without it impacting it. I think I did something bad React-wise. So I'm going to undo that. Now, in terms of the other things about architecture that TDD does a really good job of, it makes you break down the problem into bite-sized chunks. And by doing that, you actually, an architecture pattern will emerge. So it's not, you might not even write the test first. Just by trying to think of what the next test is, you'll actually think through the architectural ramifications of how you'll use it. That's a nice side effect. It's not obvious when you're doing the process, but that change in perspective of thinking, how am I going to test this thing, kind of helps you kind of make better architecture decisions in the first place. So I don't think I answered your question, but I tried. Yeah. Anything else? Yeah.
I know some people are crazy about that, but I know some people are like, all you need is 80, and that's like the spot.
All right, so Nick asked if I believe in 100% code coverage, or if there is, he's heard that 80% is usually good enough. So I am a firm believer in the 80% is probably good enough. What I always think of though is, it's like anything. If you measure it, just knowing what it is will help inform better testing. The types, depending on what tool you're using to decide test coverage, usually it looks at like 4 different things. It looks at branches, it looks at function coverage, line coverage, and is it class coverage? I'm not sure what the 4th one is. And they all come back with different percentages. So in this case, I test drove this, and it's very likely I missed some like line that I didn't know was actually needing to be tested. It might count against me that I had this box and text field here and didn't actually test that I put them there. So there's things like that throughout your code. And typically those are the things that fall into that 20% that aren't worth testing. But I'll tell you, I've gotten into code bases that are not test driven, and it's pretty obvious pretty quickly. You're looking at 30 to 40% test coverage with those static analysis tools. So 30 to 40% means somebody at least tried to write a test, but they were probably testing afterwards. Most test-driven code bases are usually between 70 and 90%. The highest one I saw the other day was I joined a team that had been writing code for 3 months, and I was surprised because their Angular app had 94% test coverage. And I was like, holy crap, good for you guys. The problem was it didn't have the right kind of test coverage. It was missing non-brittle end-to-end tests. So it actually was having problems, but it was missing those other layers. So I would say 80% test coverage on the unit test is great. Having some form of end-to-end test is probably going to make up for that 20%. And having a lot of integration tests to prove like the components working together is probably valuable too.
We got a pretty good question from the streaming audience that kind of marries up to what you were talking about right there. So this person, individual, specifically not necessarily worked on a dev team, and is curious about specifically in say like a smaller company who may not be used to doing tests. When you're doing tests, what kind of other people or teams are you communicating with to have effective testing to make that happen? Not just developers.
Got it. Okay, so I mentioned this early on in the talk, but Adam's role, and this is why I wanted him to present with me tonight, his role is mostly focused on user experience, implementing the user experience. So we have a lot of different roles on teams now, but we have somebody that's responsible for designing the user experience and thinking through how it works. And then we have people like Adam that actually implement it. They're called front-end engineers. We have developers that help wire up the front end to the back end. And then we have quality advocates, which help think of the test cases and help work through like what are the ways this is going to break or what are the ways this won't make sense to the user. And then we have a role called delivery engineers who actually help us stand up this infrastructure and these CI/CD pipelines. So I would say that everybody except for the user experience person in that team area has some influence on these tests. Different people have different influence. So our QAs generally have influence on end-to-end tests. QAs and delivery engineers have influence on end-to-end tests because you need infrastructure to be working and articulated to actually run those tests. You need a user's perspective, somebody that's advocating for the user's perspective, which is usually our quality advocates or our business analysts. So they usually help define the test cases themselves. In some cases, we have QA quality advocates that are actually automation engineers, and they'll actually implement them themselves. Developers typically worry about unit tests and integration tests, and like defects that are found will inform new test cases. Like if we fail to think of a requirement, quality advocate catches it, or product owner catches it, we'll usually write a test case to fix it. So in a way, they kind of help define the unit test cases there. But yeah, usually developers and front engineers are writing a lot of the actual unit tests. I think was that the nature of the question?
Yes.
Okay. Cool. Any other streaming ones?
That's the only one.
All right. Any more in the room? Yeah.
How do you measure coverage?
Say that again. How do you measure code coverage? So there's a lot of tools. I don't know the one in React. I can bring up an Angular project. Oh, it'll probably take too long. So React and Angular, I think they just have a command line variable. You pass it and say it's like -- coverage, and they will generate a report for you. There's third-party tools that do it, like IntelliJ has code coverage tools for probably everything, but specifically aimed at like Java. I think JetBrains has a code coverage tool called like .trace, or do you remember what it's called? Is it called .trace? That does it for C#. They're what are called static analysis tools. So they compile the code and they put hooks in there listening for what code gets called, and then they run the tests and say, what did this test actually call in the code? And then they do some diff analysis to decide what coverage it is. So it's usually built into the test running tool itself. So the JavaScript frameworks, usually it's built into their framework. I'm sure Vue has one too. I don't know. Good question though.
That's a good question.
Any other questions? All right. Well, I'm glad I started a little early. Thanks, everyone.